All right, let's take a look at the next few examples first, simplifying with rational exponents. So in problem number 14, I have a to the 1/2 and b to the 5/6. Now, if I went into radical notation right away, this would be the square root of a times the 6th root of b to the 5th. And we talked about how when we're multiplying radicals, they have to have the same index in order to multiply them. So this is something that we couldn't do before that we can now go back and do. So this, in radical notation, I can't do anything about it. What I can do is I can manipulate the fractions so that I have a common denominator, meaning they'll have the same index and they can go together. So instead of going straight to radical notation here, what I want to do is I want to make the denominators the same because then they'll have the same index. So we want a common denominator because a common denominator means we have the same index, okay? So we can make one radical. So I'm going to take that a to the 1/2. I'm going to make it a to the 3/6. So then both of them are the 6th root. So I can put them together inside of 1/6 root together and make that a to the 3rd and b to the 5th. That will be in simplest radical notation. So I want to manipulate again the index or the denominator to be the same so I can write one radical instead of two. Okay, so that's the final answer for number 14. Right? 15 is the same idea, it's the same principle, but now I have 3 different denominators that I need to make common. Okay? So again, you want to focus on the denominators because those are the indexes, the indices. Okay? And I want a common denominator. So the common denominator for 2, 4, and 3 is a 12. So I want to make this x to the something over 12, y to the something over 12, and z to the something over 12. Okay? So to make this 3/2 into a 12, I have to multiply the 2 by a 6, so 3 times 6 is 18. To get the 4 to be a 12, I have to multiply by 3, so 3 times 3 is 9. To get the 3 to be a 12, I have to multiply by 4, so 1 times 4 is 4. And now I can write this all as the 12th root of x to the 18th, y to the 9th, and z to the 4th. So now I have a single radical expression here. Okay. The only problem is I have an exponent here that's bigger than the index, so that part's going to reduce. So I need to continue to reduce here. So I'm actually going to switch this. I'm going to split this x to the 18th into an x to the 12th times an x to the 6th, because those two would add to 18, and I can do the 12th root of x to the 12th because the exponent and the index match. Then keep the y to the 9th and the z to the 4th. The 12th root of x to the 12th is an x. Because it was an even index with an odd exponent result, I need absolute value around that x. And then the remaining part, inside the radical, I have the x to the 6th, the y to the 9th, and the z to the 4th. So this is my final answer for number 15.